Okay, so uh, I think we can all agree we all love amazing visuals, right? Like those super crisp, clear images that just make you feel like you're right there in the action.
Yeah.
Whether it's a game, a movie, even just working on something, like a spreadsheet or whatever. But getting that level of detail, that takes some serious power, and that can get expensive pretty fast.
Yeah, for sure.
So that's what we're diving into today. We're talking upscaling technologies, specifically AMD's FidelityFX Super Resolution, or FSR for short,
Right.
and NVIDIA's Deep Learning Super Sampling, better known as DLSS.
Yep.
We got a really in-depth comparison document to guide us here.
Yeah.
Uh, Trust me, it gets pretty technical.
Yeah.
But our goal today is to really pull out those key bits of info that are going to be useful for you, whether you're a gamer, a video editor, or just someone who wants the best possible picture, without breaking the bank.
Absolutely. I think, it can be a really daunting landscape to kind of navigate all this stuff. But what I think is so fascinating is that these technologies aren't just for like hardcore techies anymore. I mean, they're becoming essential for anyone who works with or even just enjoys high resolution content.
So before we get too lost in the acronyms here,
Yeah.
can we break down what FSR and DLSS actually do? I mean, boosting performance, AD image quality at the same time.
Yeah.
Sounds a little too good to be true.
Yeah, it does sound a little bit like magic, right?
Yeah.
But the basic idea is actually pretty clever. So imagine you're trying to display a super high resolution image, like 4K or even 8K. That's a ton of pixels for your computer to deal with.
Right.
So both FSR and DLSS specifically like let your computer cheat a little bit.
Uh-huh.
They render the image at a lower resolution first, which is less work for the system. And then they use, some fancy techniques to upscale it back to that target resolution. It's kind of like taking a blurry photo and magically making it sharp again.
Okay, so that's the what, but the source we're looking at today digs into the how. And this is where it gets really interesting because they use totally different approaches, almost like two different schools of thought here.
Exactly. So FSR 2.0, which is the latest version from AMD, it uses really sophisticated algorithms. So think of it like a team of like brilliant mathematicians who figured out how to fill in the missing details, smooth out the edges of that lower resolution image.
Interesting. And DLSS, this is where AI comes into play, right? Like it's got a super powered Photoshop wizard working behind the scenes.
Exactly. DLSS relies on the power of artificial intelligence and specialized hardware called tensor cores. These are like tiny little brains that you find on NVIDIA's RTX graphics cards. And these tensor cores have been trained on massive data sets of images, so they've learned to predict what the missing details should look like.
So it's algorithms versus AI. It's a real clash of the titans here.
Oh, yeah.
It seems like DLSS had a little bit of a head start, though, in this race.
That's right. Yeah, the first version of DLSS came out back in 2019, whereas FSR 1.0 arrived in 2021. But you're right, FSR is catching up quickly, especially with the release of FSR 2.0. And you know what's great about this? Is that this competition is really pushing both technologies to get better and better all the time, which is good news for us, the consumers,
Yeah.
right? Yeah.
Well, I bet the question on everyone's mind is which one looks better?
Yeah.
Is it a clear knockout, or is it more nuanced than that?
It's definitely more nuanced. The results can vary depending on the game, the settings you're using, even the specific scene that you're looking at. But generally speaking, DLSS tends to have the edge in terms of just pure image quality.
Okay, so the source mentions that DLSS uses temporal data. I'm guessing that's more than just looking at a single frame.
You got it. Yeah, temporal data means that DLSS is analyzing previous frames as well, not just the current one. So it's almost like it has this photographic memory for the scene, which helps it reconstruct the images with incredible accuracy, sometimes even exceeding the quality of native resolution, which is pretty amazing. And one of the cool things about this is that it reduces those nasty artifacts that you sometimes see with upscaling, especially when things are moving quickly on the screen.
Gotcha. And then there's this whole frame generation thing with DLSS 3.0. This is where it really starts to sound like sci-fi,
Right.
like it's inventing entirely new frames.
It's pretty wild. So what DLSS 3.0's frame generation does is it analyzes motion and predicts what should come next. And then it inserts these brand new frames into the sequence. Think of it like adding extra pages to a flip book
Okay,
to make the animation smoother.
gotcha.
And the result, you get this insanely fluid performance. Especially in fast-paced games, you can really notice the difference.
Okay, so that's super impressive. But the source also mentions that FSR 2.0 has made some big leaps in image quality as well.
Absolutely. FSR 2.0 was a huge step forward for AMD. It's much closer to DLSS in terms of visual fidelity now. And honestly, in a lot of cases, you might not even be able to tell the difference.
But are there still some scenarios where FSR might show its limits?
Yeah, that's right. It can still struggle with certain types of content, like super fine detail or really fast motion. So you might see some minor artifacts, maybe a little bit of blurriness compared to DLSS in those situations. But both technologies do offer a range of quality settings, so you can tweak things and find a good balance between performance and visuals. It's really all about finding what works for you and your particular setup.
Right. And speaking of setups, let's talk performance for a second.
Yeah.
I mean, nobody wants to be staring at a slideshow, whether they're gaming, editing, or just trying to get work done.
Right.
So how do FSR and DLSS stack up in the buttery smooth visual department?
Well, the good news is that both technologies deliver a significant boost to your FPS, which is frames per second. And the higher that FPS number, the smoother everything's going to look. Think of it kind of like the frame rate of a movie, you know?
Right.
Once you experience high FPS, it's really hard to go back.
I can imagine. And a source does highlight a pretty big difference between the two here. FSR seems to be the champ for people who might not have the latest and greatest hardware.
Yeah, and that's because FSR is less demanding overall. It can work its magic even on older PCs because it doesn't rely on those specialized tensor cores that DLSS needs.
So if you're on a budget, or maybe you have an older system, FSR might be your new best friend.
Mm-hmm.
But if you've got the hardware to support it, DLSS is the way to go to really unlock that next level performance.
Yeah, exactly. It's really a trade-off. Do you need something that works on a wider range of systems, or are you going for that absolute bleeding edge in performance and image quality?
Right.
The choice is yours.
Yeah. But speaking of choices, we should probably talk about compatibility, because this isn't a one-size-fits-all situation.
Yeah, definitely not.
I bet people are wondering what kind of hardware they actually need to use these technologies. And I'm guessing the answer is different for FSR and DLSS.
You're absolutely right. The hardware requirements are one of the biggest distinctions between them. FSR is really the open source hero here. It plays well with a wide range of graphics cards. AMD, NVIDIA, even some Intel integrated graphics. If you've got a reasonably modern PC, chances are FSR will work for you.
So DLSS is strictly an NVIDIA club then?
Pretty much, yeah. DLSS is tied to NVIDIA's RTX family of graphics cards, specifically those with tensor cores. So if you want to experience the full power of DLSS, you're going to need an RTX card from the 20 series, 30 series, or newer.
Okay, so that's definitely something to keep in mind if you're thinking about upgrading your graphics card, and DLSS is on your wish list.
For sure. And it's worth pointing out the trade-off here, too. So FSR's broad compatibility means it's accessible to a lot more people. Whereas DLSS, while it requires, a specific investment, it can unlock those top-tier performance gains that we were talking about earlier.
Right, right. Well, we've been focusing a lot on gaming so far.
Yeah.
But let's not forget that these technologies have huge GE implications beyond that,
Oh, absolutely.
We're also thinking about video editing, generating content, even just watching 4K and 8K videos.
Yeah, you're right. While FSR and DLSS were kind of designed with gaming in mind, the underlying tech is incredibly powerful for anyone working with high-resolution video. And as we move further into this world of 8K and beyond, this is only going to become more and more important.
Yeah, for sure. And the source makes a really interesting point about FSR's potential in video editing. It seems like being open source gives it a real advantage in that area.
Exactly. Because FSR is open source, it can be integrated into a much wider range of video editing software. So that makes it super flexible for editors. Think about it. If you're using software that supports FSR, you can potentially leverage its upscaling powers to preview your 4K or even 8K edits in real time, and your computer's not going to, slow to a crawl.
Right, which is a game changer for anybody who's ever struggled with editing, high-resolution footage.
Yeah, big time.
So where does DLSS fit into the picture then when it comes to video?
So DLSS might be a bit more limited in terms of software support for now, but don't underestimate its potential. Remember, DLSS brings that AI power to the table, right? And in the world of professional-grade video, that AI can make a huge difference. Think about things like better upscaling, maybe even noise reduction, and potentially even more advanced features down the line.
Okay, so even though it's not as widely supported in editing software yet, DLSS could be kind of a secret weapon for video professionals, working with NVIDIA hardware.
Absolutely. It might require more specific setup, but the potential benefits are definitely there.
So all this talk about incredible visuals and this cutting-edge technology, I'm ready to go build a supercomputer. I have a feeling some of our listeners might be feeling the same way. So let's say someone out there is inspired to go build or upgrade their PC for the ultimate video editing experience, and maybe some high-end gaming too. What are those core components they should be thinking about?
Okay, well, if you're building a system for demanding tasks like 4K and 8K video editing, we can't cut any corners. So let's start with the heart of the system, the CPU, or central processing unit.
Okay.
For video editing, you want as much processing power as you can get, right?
Right.
We're talking multiple cores that can handle those heavy workloads. And if you're going all in on DLSS, a CPU with a high core count is going to help you get the most out of it, especially for video editing. Think of it like having a team of super fast chefs all working together to prepare this really complex meal.
So what are some of the top contenders in the CPU arena?
Well, at the very high end, we've got the AMD Ryzen 9 7950X. It's a beast of a processor, 16 cores, 32 threads. And from Intel, we have the Core i9 13900K, boasting a whopping 24 cores and 32 threads. Both of those are powerhouses for both single-threaded and multi-threaded performance. But keep in mind, these top-tier CPUs do come with a premium price tag. They're not going to be cheap.
Yeah, that makes sense. And I'm guessing the graphics card is just as important, especially with FSR and DLSS in the mix.
Oh, absolutely. For 4K and 8K video editing, a powerful GPU is non-negotiable. And this is where your choice between DLSS and FSR really comes into play. If you're aiming for that ultimate performance and image quality, and you're willing to invest in an NVIDIA RTX card, then DLSS is going to be the way to go.
So I'm sensing we're about to drop some serious GPU names here.
All right, at the very top of the food chain, you've got the NVIDIA GeForce RTX 4090. This is like the king of all GPUs right now, offering exceptional performance for 8K editing and real-time rendering, but be prepared to pay a king's ransom for it.
Wow, that's a lot of power. But what about folks who might be, Team AMD, or just don't need that absolute bleeding edge of performance?
Well, then you're looking at cards like the AMD Radeon RX 7900 XTX. It delivers fantastic performance for high-resolution editing, and it offers really robust support for FSR. So it's a great option if you're not ready to, fully commit to the NVIDIA ecosystem.
So we've got our CPU and GPU sorted. What else do we need to consider for this dream video editing rig?
Well, we can't forget about RAM. For smooth multitasking and handling those massive video files, you'll want at least 32 GB of DDR5 RAM. But if you're really serious about 8K editing, 64 GB or more is highly recommended.
Okay.
And then there's storage. Fast storage is absolutely crucial for video editing, especially when you're working with large files. So you'll want a speedy NVMe SSD for your operating system and applications. And for storing all your media files and projects, you could go with another NVMe SSD or a slightly less expensive SATA SSD. You've got options there.
It sounds like we're building quite the beast here. I'm guessing we need a pretty hefty power supply to keep all these components running smoothly.
Absolutely. For a system like this, you'll want at least an 850-watt power supply. But for those top-of-the-line components, like if you're going all out, a 1200-watt power supply is even better. Gives you a bit of headroom.
And of course, we can't forget about keeping all that hardware cool.
Right. High-performance components, they generate a lot of heat, and we need to keep them from overheating. So for the CPU, you can go with a high-performance air cooler or maybe a liquid cooler. And don't forget about case fans. Make sure your case has good airflow to help dissipate all that heat.
Okay. I'm starting to feel like we're assembling a spaceship here.
Right.
And to pilot this spaceship, we'll need a pretty impressive monitor, right?
Right.
Especially if we're working with 4K and 8K content.
You bet. For video editing, color accuracy and high resolution are essential. So there are some fantastic 4K monitors out there that offer stunning detail and really accurate colors. And if you're venturing into the world of 8K, there are even monitors that can handle that extreme resolution, although be prepared to pay a premium for those.
Wow. This is a lot to take in. But even if someone isn't ready to go build a system from scratch, understanding these components can still be super helpful, right?
Absolutely. Whether you're looking at pre-built systems, considering some upgrades, or just want to kind of know what's out there, understanding those core components is crucial.
Well, we've covered a lot of ground in this first part of our deep dive, from, demystifying FSR and DLSS to planning out a dream video editing setup. We've explored the core technology and how it impacts the way we experience visual content.
Yeah, it's been a good start.
But we're not done yet. In the next part of our deep dive, we're going to delve deeper into the performance differences between FSR and DLSS, explore how they're being used in some really cutting-edge applications, and even take a peek into the future of these exciting technologies. So stay tuned.
Yeah, it's going to be good. So welcome back to the deep dive. Before we, jumped into that whole hardware side of things, we were talking about how both FSR and DLSS can really elevate the visual experience, whether you're into gaming or editing.
Yeah, exactly. Definitely laid the groundwork there.
Yeah.
But I think it's time to put these technologies head to head. Let's talk about real-world performance. Everyone wants smooth visuals, but how much of a difference do FSR and DLSS actually make?
Well, the good news is both technologies can significantly boost your frames per second,
Hmm.
or FPS, which basically just means how smooth the motion looks on your screen. The difference can be like really dramatic, especially if you're trying to push a lot of pixels, like with 4K and 8K resolution.
Okay, but when it comes to pure performance games, is there a clear winner, or does it really just depend on the situation?
It definitely depends. If we're talking about just raw maximum performance, like squeezing every last frame out of your system, DLSS, with its AI-powered frame generation, has the potential to deliver some really mind-blowing results, especially in fast-paced games.
Right, we talked about frame generation before, where DLSS 3.0 is actually creating new frames based on what's happening in the scene, right? It's almost like the AI is predicting the action before it even happens.
Exactly. And that can lead to incredibly smooth performance, even if your hardware is struggling to keep up with the demands of the game.
But DLSS's frame generation, that only works with certain NVIDIA RTX graphics cards, right?
That's right. You need an RTX card from the 40 series to take advantage of frame generation. But
Yeah.
even without frame generation, DLSS can still give you impressive performance boosts thanks to those tensor cores we talked about and, its sophisticated AI algorithms.
So where does FSR fit into this whole performance picture then?
So FSR might not have the raw horsepower of DLSS when it comes to absolute peak performance, but remember, it's designed to work on a much wider range of hardware.
Right, which means even folks with older PCs or those who aren't ready to invest in an NVIDIA RTX card can still benefit from upscaling. It's really about opening up that world of smooth, high-resolution visuals to a much bigger audience.
Precisely. And, the developers of FSR, they're constantly working on improving both its performance and image quality. We saw huge improvements going from FSR 1.0 to FSR 2.0, and I'm sure they've got even more exciting stuff in store for the future.
So it sounds like both FSR and DLSS have their strengths and weaknesses when it comes to performance. If you're going for that absolute bleeding edge and you've got the hardware to back it up, DLSS might be the way to go. But if you need something a bit more versatile, more accessible, FSR is a fantastic option.
Yeah, I think that's a really great way to put it. Performance is only part of the story, though. We also need to talk about how these technologies are actually being used in the real world.
Right. I mean, we've focused a lot on gaming, which makes sense, considering that's where these technologies were initially developed, right?
Yeah.
But I'm really curious about how FSR and DLSS are being applied in other areas, especially as 4K and 8K resolutions are becoming more and more common.
Well, one area where we're seeing a lot of really cool developments is in video editing. As you can imagine, editing high-resolution footage can be super demanding on your hardware. But FSR and DLSS are changing the game by making it possible to work with 4K and even 8K video much more smoothly and efficiently.
Yeah, I can imagine how helpful that would be for video editors. Being able to preview your edits in real time without your computer like chugging along, that would be a dream come true. But what about beyond video editing? Are there other applications where these technologies are, making a difference?
Oh, absolutely. Think about, anything that involves rendering or processing high-resolution images or video. So we're talking 3D modeling, architectural visualization, even things like medical imaging. FSR and DLSS can help speed up these workflows and make them more accessible to people who might not have access to, the most powerful hardware.
So it sounds like these technologies are kind of having this ripple effect across a whole range of industries.
Yeah.
It's not just about making games look prettier anymore. It's really about pushing the boundaries of what's possible with visual content in all sorts of fields.
Exactly. And I think this is just the beginning, honestly. As FSR and DLSS continue to evolve, I'm sure we're going to see even more creative and innovative applications emerge. The potential is really limitless. But, we've been talking a lot about the present and the near future. I'm kind of curious to hear your thoughts on the more distant future. Like, where do you see these technologies going in, say, 5 or 10 years?
Oh, that's a great question. I think it's safe to say that the line between, what's real and what's virtual is just going to become more and more blurred as these technologies advance.
Yeah.
Imagine a world where you can experience a live concert in virtual reality with such incredible detail and realism, it feels like you're actually there in the crowd. Or imagine being able to explore, like, historical sites or distant planets in a fully immersive, photorealistic environment, all from the comfort of your living room.
Those are some amazing possibilities. I think they're definitely within the realm of possibility. As AI and hardware continue to advance, we're going to be able to create these virtual experiences that are virtually indistinguishable from reality. And FSR and DLSS are going to play a key role in making those experiences accessible to a wider audience.
Right, so we talked about how these technologies are already impacting gaming, video editing, and other fields. But what about their potential impact on, like, education or healthcare, even scientific research?
Ooh, yeah, that's where things get really exciting. Imagine medical students being able to practice complex surgical procedures in, like, a hyper-realistic virtual environment. Or architects designing buildings with the ability to visualize every detail in real time. And think about the possibilities for scientific research. Being able to visualize these complex data sets in 3D or simulate complex scientific phenomena with incredible accuracy could lead to breakthroughs in all sorts of fields, ranging from astrophysics to medicine.
It sounds like we're on the verge of a visual revolution. And it's all thanks to these amazing technologies that are just pushing the boundaries of what's possible with visual content. But we've covered a lot of ground in this deep dive. I think it's time to zoom out a bit and think about what all this means for our listeners.
You're right. I mean, we've been digging into these technical details, exploring the different applications, even speculating about the future. But what does all this really mean for someone who's just trying to understand how these technologies might impact their own life?
Well, I think the key takeaway is that FSR and DLSS are making these high-quality visual experiences more accessible than ever before. Whether you're a gamer, a video editor, or just someone who enjoys, watching movies and TV shows, these technologies are really enhancing the way we consume and create visual content.
And as resolutions continue to increase, FSR and DLSS are just going to become even more important. They're going to be the key to delivering smooth, stutter-free performance, even on devices that might not have the most powerful hardware.
So what advice would you give to someone who's trying to decide whether FSR or DLSS is right for them?
I would say, the first step is to consider your hardware. If you have an NVIDIA RTX graphics card, then DLSS is definitely an option worth exploring. But if you have an AMD card or maybe an older NVIDIA card without Tensor cores, then FSR is a fantastic choice.
And what about folks who are thinking about upgrading their hardware? Should they factor FSR and DLSS into their decision-making process?
Oh, absolutely. If you're planning on building a new PC or upgrading your existing one, it's definitely worth thinking about, which technology you want to prioritize. If you're going all in on DLSS, then you want to make sure you choose an NVIDIA RTX graphics card that supports it. But if you're more interested in FSR, then you have a wider range of options since it works with both AMD and NVIDIA cards.
It sounds like there's really no one-size-fits-all answer when it comes to FSR and DLSS. The best choice just depends on, your individual needs and preferences. But one thing's for sure, these technologies are really revolutionizing the way we experience visual content. And the future is looking super exciting.
I couldn't agree more. It's an amazing time to be following this field. We're seeing just incredible innovations emerge all the time, and I can't wait to see what the future holds. But we've been talking for quite a while now, and I'm sure our listeners are eager to hear, what final thoughts we have in store for them.
You're right. We've explored the technology, the performance, the applications, the future of FSR and DLSS. But before we wrap things up, we want to leave you with one final thought, something to spark your curiosity and maybe even inspire you to explore this whole fascinating world a bit further.
Yeah, we've talked about how FSR and DLSS are changing the game for, gamers, video editors, anyone who works with high-resolution content. But what about the bigger picture? How are these technologies going to shape the way we interact with visual content in the future?
Ooh, I like where this is going. It's like zooming out from all those technical details and really looking at the broader impact on our digital lives, right? Like it's not just about making things look better on our screens, It's about how these technologies could actually change, like our whole relationship with visual content in the future.
Yeah, exactly. Imagine streaming services being able to just pump out this ultra high resolution 8K content to all your devices, even if you don't have the latest and greatest hardware, or editing 4K video on your laptop without, everything slowing to a crawl. And think about virtual reality experiences. They could become so realistic, they're basically indistinguishable from real life.
Okay, that is next level. It sounds like FSR and DLSS, they could really be the key to unlocking this whole new era of visual fidelity. And what's great is that it makes it more accessible, Not everyone can afford to keep upgrading their hardware all the time, right?
No, definitely not. And I think you're right. I think they could be the key. And, it's not just about entertainment either. Imagine the potential impact on education, healthcare, even scientific research.
Hmm.
Being able to visualize complex data, simulate real-world environments, or even experience historical events in, like, stunning detail. The possibilities are, pretty much endless.
Yeah, it's kind of mind-blowing to think about the ripple effects these technologies could have. We're not just talking about prettier graphics here. It's about changing how we learn, how we work, even how we experience the world around us.
Exactly. And the cool thing is, this is just the beginning. We're still in the early stages of what FSR and DLSS can really do.
It's crazy to think that just a few years ago, this kind of tech would seem like pure science fiction. Now it's rapidly becoming just, a normal part of our everyday lives.
One thing that really fascinates me is the role of AI in all of this. We've seen some pretty mind-blowing AI-powered features already with like DLSS's frame generation. What other kind of like AI magic can we expect to see in the future of upscaling?
Yeah, where does the line even start to blur between reality and AI-generated content? That's kind of like a whole other philosophical debate there.
Well, just imagine AI algorithms that can not only upscale the image, but actually like enhance it in other ways. So like automatically removing noise, maybe sharpening details, even adjusting the colors and lighting. It's like having this virtual cinematographer working alongside you, constantly tweaking things to like make the image look as good as possible.
That's incredible. It's like we're on the cusp of a visual revolution. And as we keep moving into this world of, 4K, 8K, even higher resolutions, these technologies are only going to become more and more essential.
Absolutely. Think about it. As resolutions increase, the demands on our hardware skyrocket too, right?
Oh, yeah.
So FSR and DLSS, they're going to be key to making those higher resolutions more accessible and ensuring, everyone has a smooth, enjoyable experience, even if you don't have the absolute latest and greatest tech.
So we've covered a lot of ground today, from like the really nitty-gritty technical details to some pretty wild possibilities for the future.
Yeah.
But before we wrap up, I want to bring it back to our listeners. What's the one key takeaway they should walk away with today?
If I had to boil it all down to one thing, it'd be this. FSR and DLSS, they're not just about making things look prettier. They're fundamentally changing how we experience and interact with visual content. And, the best part, we're only just scratching the surface of what's possible here.
I love that. So to our listeners out there, whether you're a gamer, a video editor, or just someone who appreciates a, truly stunning visual experience, FSR and DLSS are definitely technologies worth paying attention to. They're shaping the future of how we see the world, both the real one and the virtual one.
And remember, the best way to stay ahead of the curve is to stay curious. Keep exploring, keep learning. Who knows what amazing visual experiences await us, in the years to come.
We'd love to hear your thoughts on FSR and DLSS. What excites you most about the future of upscaling? Share your thoughts and let's keep the conversation going. Until next time, thanks for joining us on this deep dive.